recording, and welcome to this new session of the Python workshop. And this time, big thanks to Ellie, who managed to pull off a presentation on a very short notice. And they will speak to us about Clean Code book by Robert C. Martin, who didn't write Game of Thrones, I believe. Okay.
Thanks, Flavia. So yes, this is the book. I don't know if you can see it on the camera. And it was recommended to me by a friend who is a software engineer, I guess. Um, and yeah, he told me in the new place he was working on, this was their Bible, and that he learned some cool tricks in there. And so I read it, and it did indeed improve my coding abilities. So my problem was that when I was coding long things, they started to the longer I coded, the slower it became to code more. It was hard to add any new functionality, and debug was hell. When I found a bug, it was like a cold shower, and I knew I was on for a battle. Uh, and yeah, just it made it not fun to work on my big projects. And coding is fun. It should be. Um, some background. I know algorithmic. I know the theory of coding quite okay, but I don't know software coding in any shape of or size. So I'm really not an expert in theory, and what I'm going to present to you are very simple tricks. And don't hesitate to interrupt me to add some of your knowledge to this presentation. Um, so first, okay, we are going to talk about clean code, meaning good code. So what does it even mean? And one definition that I like is not about how to define it, but what it does. So you have a project, you start with, oh, I want to code this thing, I'm writing it. And then, of course, it deviates from this straight line. You realize, actually, I need this option that I didn't think of at the beginning, or maybe I make a first prototype and I realize, oh, we actually I present it to someone else and he tells me, oh, actually we need this other capability for the code. So we have to make it evolve. We have to make it different. And how painful it is to do those changes reveals how good or bad the code is. So typical bad things in code that we all know, at least in theory, code duplication. If you have several pieces of code that actually are the same, it's really bad. There are two kinds of code duplication. One is you actually have the same copy pasted code, and that's horrible, of course, because any changes you do on one of those copies is you probably also want to do those changes on the other part, and you are going to forget some of them, and then it's going to be a mess in general to maintain, I mean. And the other code duplication that exists is more on a conceptual level, when you are doing kind of the same idea again and again, but not written in the same exact way. And then probably there is an abstract function or an abstract class that should exist on top of it, and that is actually that the duplications you have could be factorized in that way using an abstract function. Bad code is, well, hard to understand when you read it. You have to, take notes or test a lot to understand what is going on. But I mean, everyone can write code that the computer understands. I don't know who said that, but it's a famous quote. Everyone can make code that the computer understands, but what makes good code is that the human reading it can also understand it. So that's a very important thing. And yes, another thing that makes bad code, and I was not aware enough of that, is long or deep functions. By deep, I mean there is an if, and inside the if there is a for, and inside the for there is a while, and those kind of indentations levels. Um, and yes, this is actually the most important thing that changed in my code and helped me a lot. So the worst that can goes on with bad code is that it becomes so hard to maintain anything that the only way is to restart. Along the process of building this huge mess, we typically learn some things about the better structure it should have. So the new version is going to be a bit easier because it starts with the right convention at the beginning. But still, if we keep the same way of coding, it's also over time going to the quality is going to decrease, and it's going to lead to the same problem. You just have to wait a bit longer this time. So that's not really a solution, and it's very painful when you have to do that. And I guess almost all of us have been there. Um, okay, and a very important observation, key observation, is that we spend more time reading code than writing it. At the beginning, we write because we know what we want, and then later on, we realize, oh, when I write a new function, I need to understand what is going on before. So we spend way more time reading than writing, even our own code, even when we are alone. And of course, if we are several people working on a project, it's going to be even worse. And so it's worth taking a little more time writing the code right and saving a lot in the future. Also, yes, everything I'm going to talk about requires an IDE because to change names easily and not be afraid to do changes in the code, of course. Yeah, I hope everyone is using one. Okay, so I'll start with the basics of good conventions, names, how to name things in the code. So first, okay, we have this classic convention, writing it with capital letters and no space, no underscore or anything. That's for classes, and some people use that also for variables with a small letter at the beginning. So it could be, for example, name of a variable. It could be like that. That's a very nice convention too, but I prefer this one just because for me, I read it, it's easier to read. So I'm going to use that for the classes because that's Python convention, and use that for everything else.
Eddie? Sorry
yes.
to interrupt. In fact, this is not only your personal preference, but it's also standard in Python.
Oh, okay. I didn't know. I thought both were acceptable in Python.
Convention would be more standard in other languages.
Yeah, C and those kind of languages. I saw a lot of those guys.
In Java, especially.
Ah, Java.
I didn't want to point finger, but yes.
because in C it would be like you wrote with underscore.
Okay, so I'm not alone. Perfect. And yeah, the ideal code can be read like a journal article. You just read the code like it's telling you the stories of how it works. And for that to happen, of course, you need names that are very clear about what they do. So for example, if you feel the need to add next to a variable you have named a comment explaining what it is, it's probably that it's just the wrong name to begin with. Yes, it's short. Yes, it's going to be shorter to write the code using D everywhere than to use a longer name, but it's going to make reading harder. And because we read more than we write, it's not worth it. Also, auto-completion in IDE are just very useful. So a couple of examples here to replace this D that is supposed to represent the elapsed time in days. So you could just say elapsed time in days. Yeah, that's obviously better than D. But it's not telling us a lot about, well, what is, it's not giving us a lot of context. And context is very important. So maybe we can do better. We can do days since creation. And now we understand that it's not only a number of days, but also what those days are about. It's about the creation of something. And even better, file age in days. And now we understand that we are talking about a file. And that was completely not clear from either the name D or even the comment here. So with a good name, we don't need this comment. And it will make the reading of the file way clearer for the reader.
Just a remark, Eli, if I may.
Yeah, of course.
Often it's a good idea to prefix the name of some function of variable according to, say, the module it lies, where it lies, because it helps when you use autocompletion to find everything which is related to something, for example. It might be interesting sometimes to choose the name and maybe swap some words to make them easier to find through autocompletion. So maybe it's not really applicable on your example, but sometimes it does.
Yeah, okay.
Sorry, just want to add a remark to the remark. In some IDEs like PyCharm, for example, you have the autocompletion not only on the first word of the variables, but also on following words. So even if the word that interests you is the last word of the variable, it will appear when you will when you will put DAY, for example, it will propose you file age in days.
And that's very interesting because when you read variables, you typically read the beginning of it, and then you recognize in your head you say, oh yes, file age, yes, I remember the end is in days, I don't need to read it anymore. You read it on your first pass, on the second pass, and then when you scroll with your eyes through the file, you don't read the end anymore. So if you want to add information that is going to be useful for your tools, like your IDE, like Marco said, I think it's a little bit better to have it at the end of it more than at the beginning, because at the beginning it will make the reading a bit longer every time. So I prefer the important thing about the variable to be more at the beginning than the end. I mean, important from the human's perspective, from the reading perspective. So here is an example taken from the book directly. And we can read it. Get them the list. Res is an empty list. For x in the list, if x0 is 4, so x list, we understand here that list contains things that are themselves maybe lists. We append x to res, and then we res. So res is probably result in that case, okay. And we understand what it does, of course, but we understand, and yes, there is a one-liner for that in Python, because Python, the book is written for Java, by the way, but I mean, the concept applies to any language. But yes, we understand nothing. We have absolutely no context from this function. What is this 0? What does that mean? What is this for? How is that, important for anything? What is the list? What is this function for? No context at all. And we could have, with better names, given a lot of context here. So first, define constant values for the 0 and the 4. And actually, this function was about a Minesweeper game, and there were some cells that were flagged, and so we want to collect them. So get flagged cells is working just fine. Now the list is not the list, it's the game board. The flag cells are the empty list at first. The cell in game board, we can check that the status value is flagged, and if that's the case, then we add it. And now it's telling really a story. It's way easier to understand from a human perspective, because the things are not abstract computer objects. They are actually a game board, there are cells and those kind of things. I didn't change the structure at all. It's exactly the same. But now we really understand it way better. And so in order to make the thing readable, the code readable like a journal, we need also not only clear names, but very often the name of methods and functions should be verbs because they do something, do something. Add, save, is for tests, is even for an integer, and then if is even your integer, and then you do something, so it makes sense. And yeah, I think that's all I wanted to say about naming conventions. Oh yeah, no, yes. You can, yes, several things actually. You can choose your name in computer science because people who are reading your code are computer scientists, most likely. You can, and they know a bit of math too. But your code is always working typically about solving some problem from the outside world. So if there are no names from computer science, you can also use name from there, from the problem you are tackling. Um, of course, you should try to keep one word per concept. That makes sense. And don't hesitate to change name when you find better ones. And to be honest, I spend a lot of times finding better names, and my IDE is helping me a lot to do those changes painlessly. Because yes, it has no cost to introduce a better name, so I do not hesitate anymore to do it.
Just a remark, if I may.
Yeah.
I think it's important to well choose the verb. So, for example, to retrieve a value in practice, everyone use get something. But get something usually means that the complexity is O of 1. And if you have to compute something, you should choose another verb, for example, make or compute or whatever.
Yeah.
It's important because sometimes people won't read your code or even the documentation of your function, if any. And so the verb will be very useful to have an insight of how costly is your processing.
Yeah, I completely agree with you. And what you point out here, there's a more general thing about it is sometimes we write code and we add in the description of the function or somewhere the information about it. And we say, well, it's good enough because the information is in the documentation. The reader just needs to read that. But no, the reader should not have to do that much. It should be clear just from the name what are going to be the arguments, their order, what it's going to do, and sometimes okay, you can't put everything in the name, but the most of it you should try to put as much as you can on the name. And not expect your reader to go to the documentation every time for every little thing. Yes, the information exists somewhere, but it's not user-friendly. Okay, and now we're going on the part that is the most important, where I really learned something. So when when I read two codes doing the same things, I was able to tell which one was the cleaner one. I had intuitions about it, and I guess you too. But what this gave me are recipes to actually recognize good code and to help me transform my bad code, realize that my code is bad. It was not completely obvious to me when I saw just one code to know it's bad or good. By comparison, I could decide which one was better, but alone, it was not that easy. And now I have criteria, I have ways to say, this is probably not the best. We can probably do something, and how to do something to improve it. So that helped me a lot. Function should be short, and by short, the Robert Martin means really, really short, with few arguments. 0, 1, or 2. 3 is already a lot of arguments in his mind, and low indent level. So not many things, not if, for, while inside each other. They should do one thing and only one thing. Work at one level of abstraction, and also avoid in functions the side effects. It's preferable that a function output something because it's easier on the mind of the reader because he sees what is going on. There's nothing hidden when the function is applied. There's nothing happening in the background that is unclear. So the good things about those principles, and I will, spend more time on them, of course, is that the code can be read like a journal. It's easier to understand. It's easier to test. We will see that too, and it makes the structure clearer. When you write in that way, or when you transform code that was different into that way, it makes the structure of the code clearer, and then you understand better what is going on, and it helps a lot. So it's a bit longer. The code tends to be longer with that, of course. And typically, your first try is not going to be functions like that. Even when I know that's what I should have at the end, my first try is not like that. And then I just do a second pass and improve it. So it takes a bit more time. But it's absolutely worth it as far as I've tested it. So here's an example taken from the book. So we write, okay, let's read it. I tried to choose the name in a clear way. I changed a bit the name he had, so you can correct me here. So print message for counting. I'm not completely happy with it, but yeah, okay. There is a count, that's an int, and there is a name of what is counted. Okay, if the count is 0, there are no name of what is counted with an S. Okay, that's because English is strange. If there is 1, then we write there is 1, name of what is counted, and there is no S. And else we print there are the number. There are spaces everywhere, and name of what is counted with an S because there are several of them. So we can test that. 0 banana, there are no bananas. There is 1 banana, or there are a lot of bananas. Okay, that's clear. I think the name maybe is not absolutely clear, but we understand what is going on when we read it. Okay. Maybe that's good enough for your code. Maybe you don't need to improve that anymore. Or maybe you see here this line and this line and this line as code duplication. Who would have said that's code duplication? I don't know. It depends really if you have many messages of this kind and if you have the hope of factorizing more after that. But yeah, let's say this is a tiny example. But let's say, yeah, this is code duplication. We don't like it. It's a problem for us in a project. So how are we going to avoid this code duplication? Well, we can write this second version. We have count again. The number, if the count is 0, then the number, the string representing the number is no. The verb is are, and the plural modifier is s. If the count is 1, then the number as string is 1, is, and there is no plural modification, and so on and so forth for the next one. So what we are saying that there, this was code duplication, and now we are looking at what changes actually. Those guys changes, that's the verb. This is the number, that's changes, and here at the end we also have part that changes. So those parts, we look at the different cases, and then we finally print the message we wanted to print. Okay, and we can test it, it works just fine. Okay, that's okay. And that's now a long function, as you can see. And also it's doing a lot. So we don't like that it's long. We don't like that it's working on different things. It's doing a lot of things. What I mean by that, it's building a message. That's this part. And then it's also printing the message. So maybe the printing should be when we have several things inside the same function, some of the abilities have to go either up or down. And here we are going to see on this example both. The print is going to go up. Instead of having this function that builds the message and print it, we are going to make a class, message for accounting, and printing is going to be printing this is going to go up. So it's when we want to print message for accounting, we write print message for accounting, which is very readable, by the way. It makes a lot of sense. Some other things are going to go down. Here we test in which case we are, and depending on those cases, we do things that really are about lexic, about the language. So those are two different levels of abstraction. You see, two different kinds of operations, and we could separate them. And that's what we are going to do in our class. So in the init function of a class that take as input the same things as a function, what we are going to do is test in which case we are, and that's it. Then just call the right function to do the things for each of those cases. And those functions, so here we only do testing in which case we are, and in those functions we are working only on the linguistic part of the problem.
Small remark, if I may.
Yes.
So I think that the important takeaway of what you say is to separate the intelligence and the display. It's very important because for the moment you are doing a print, but maybe later you want to craft a message for, say, a website. I don't know. And so you don't know, or for graphical interface or whatever. And so you never know where your strings will be printed. That's why you want always to separate display from intelligence.
Yes.
I won't enter in the details of architecture like MVC, but it's related to this. Another remark is in my case, if I would wrote this function, I'm not really convinced that I would write 3 methods, because basically you have 2 cases. Either it's one, either it's something else, and inside something else you have the case 0 or many, because you have the verb and the plural modifier that are factorizable.
So you would say there are still code duplications between this and this, and you are unhappy about it, and you want to go further. Okay.
If you split methods like this, it won't be easy later to factorize this code. And that's why I don't think it's a very good idea in this precise example to split the language intelligence into 3 methods. But it's a personal opinion.
Yeah, okay.
Just to respond on that, so really, for instance, what I would probably do is have a kind of dictionary with one key would be 0, 0 on the item, the other key would be 1 item, the third key would be multiple items. And each value will be typically a triplet of the values that you want to number of strings and verbs. And so I will probably use a def initialize when count, off self and count. And the count will be triggered from the dictionary. This is the way I will probably do this, personally.
Yeah, okay. I agree with all of you. So this code is not mine. It comes from the book, really. So I thought, I'm just going to present it as it is.
You can
I didn't try to change it, so I can't really defend it, more than that. I agree with you. Interesting remarks, but what I find interesting about it is this idea to separate this operation, testing in which case we are, from what we are doing with the linguistic part. And also, as Marco mentioned, the most important thing really is to make the print outside of it. And what I like about this example is we just followed a few rules I mentioned at the beginning. Try to make our functions short, low indent levels, do one thing and only one thing, have one level of abstraction. So those looks like rules taken from a holy Bible or something like that. You shall do that, and it feels like, oh yes, master, I should do that because you are the master and you told me to. But no, actually, that's not how it's supposed to work. You don't have to apply them blindly. It's just that here on this small example, we see that we end up naturally putting the print outside. It makes us question where the print should be, and then we realize, oh, of course, it should be outside, and for the reason that so it goes in the direction that Marco mentioned. Maybe later on we are going to do something else with the message. And so it will make the code more robust to changes and easier to evolve.
Elie, excuse me.
Yes.
Just to nitpick a little bit more and say a variant of what Marco, excuse me, of what Marco and Fabien said. If I had to make that function, I think I would take a very simpler path. In fact, I would write almost the same as your initial version.
Yeah, I like the initial one too.
The two main differences that I would make is that I wouldn't do the print. I would return the string because, as you mentioned, it's better to return the string and do whatever you want of it afterwards. And the second modification would be to use the standard format syntax of Python instead of concatenation. But this function is so simple and so easy to read that it's not a very convincing example.
I completely agree with you. That's why that's why I said at the beginning. So okay, the print should go out definitely, and there is a better way to handle this to make it clearer what is going on. But I would only try to factorize this function more if there were other examples, and so I would think that factorizing here would lead to other factorization in more factorization elsewhere in my code. So
in fact, this factorization would be very useful if you can make a conversion to another language like French or German. Exactly the same rule and just changing the methods. But unfortunately, it's not true because even the logic of this language are not the same. For the way you distinguish between 0, 1, and many. Maybe in other language you will distinguish between 0, 1, 2, and many. So you will have to write custom functions anyway for each language.
Yes. So factorizing here could help structure it, saying, oh, we have rules that talk about plurals in French, in English, in Chinese, in whatever. Rules that talk about the verbs and those kind of things. Maybe, I don't know. Language is a mess. So, okay. So that was the example from the book. And sorry, it was not completely convincing. I hope it's because it's hard to find examples that are small enough for a presentation and that also show what you gain from good code, because, well, clean code is better when the project is a bit big, of course. So yeah, okay, let's talk about comments now. So some comments are good comments. The comments about documentation, like those guys, and comments that tell you about implementation explanation. So here, for example, we have a function that computes the square root of a variable x up to some precision. So first we test if it's if the parameters are okay. Otherwise, we send an error. Then we have to handle the case 0 on its own, and then we apply. What do we do here? That's a bit, complicated, but actually with one command we can explain, oh, that's the Newton method. Oh, okay, so now we understand what is going on. And so those are useful commands, I guess. Would you agree with that? So I guess yes. But of course, that's a joke. No, it's not a good command. It's a very bad command. First, there is code duplication here. That is very common in a while loop. You know, you initialize the variables you are doing some things on, and then you have to repeat that in the while loop. That's always very annoying because we don't have a true condition and a while at the end in Python. We have only the while at the condition immediately. Some languages have this other option, as you know. So yeah, code duplication, that's a clear indication that we can do something about this function to improve it. And also, yes, we had to add a command, but maybe with a better name, with introducing a function with a name, we would not need this command at all. So let's do that. What I'm trying to show you here is this is how I would write the function maybe on my first try, or if I was a bit drunk maybe, or something like that. I would, you know, think, oh, square root, Newton method, yes, I can write it, and just go like that. But then we can try to improve it. And what I want to show you is the process of how to improve it. So it's a very small example, toy example, but still. So, okay, maybe we want to give a name for this function that we applied here 2 times. What is it? It's the Newton, it's one step in the Newton algorithm, right? So it's the Newton square root function. That's how I'm going to call it. And I guess with here, we don't need the comment about Newton method because we see it here in the function. Okay, and I just, so now use it here and here. But now when we read it like that, so first it's very long, and then we see that there are several things that are going on here. This function square root is not doing one thing. It should be doing one thing, but it's testing the initial values, then defining this guy, and then applying, iterating this function on that. So if it's iterating the function on this Newton square root function is iterated on itself, you know, starting with some initial value, then probably we can, you know, make another function from that. So this last part, we can make a function out of it. And what is this function doing? It's doing something very abstract, actually. It's applying a function again and again and again on an initial value until the difference between two applications of the function is smaller than precision. So we are iterating a function that is converging to something. That's very abstract, that's very general, that's one level of abstraction. And it makes sense. We can clearly see that we are going, if we write another function with the Newton method, we are going to also to use this again. So it's way better now. But still, a function here is still doing kind of 2 things. Testing the initial values and then applying the Newton method. So this part is actually computing the square root when the value is strictly positive. So we can give a name for that. And now it looks like that. And I think I'm happy with that. That would be clean code for me. We have the square root function. We have some commands for the documentation because the user is going to use that square root function, nothing else. Here we test the initial value. And either it's 0 or negative and we have some errors, or then we can take the square root of a positive value. And when you read it, it makes a lot of sense. You know, it's just a simple story. Oh, x is negative or the precision is negative. Okay, of course, that's not good. If is null, 0, okay, the square root is 0. Or we are taking the square root of a positive value. Yeah, that makes sense. I'm happy with that. And then I decide as a reader, do I trust the lower levels of the code or do I need to go lower? If I need to go lower, I can read actually this function. So it's here. What is it about? oh, I defined a Newton function stuff. Oh, so I'm probably applying the Newton method. Okay, and then I iterate my Newton method on the initial value x until precision. Okay, so maybe that's the right level of abstraction I want to go to. Maybe I don't need to go to know the details about these iterating things, but if I do, it's just under here, so I can read it, and yeah. Would everyone agree that if we compare both this code and this code, this is way cleaner? I hope you can, feel it. I hope it makes sense. And this is shorter. So one would think, oh, I'm going to spend less time writing it because it's less things to type on the keyboard. But actually, this is going to save so much time because when I have a bug, I'm going to find which one is responsible way more easily. I'm going to test those things way more easily. And so I'm going to save a lot of time in the long run. So it was worth spending a bit of time on this guy to improve it and make it that. So yes, I claimed I was going to talk about comments and I lied. I just wanted to give a second example that is from me and that I find a bit more explicit than the first example about what it means to make small functions, how to recognize that we can do it, and how it helps improve the structure. And yes, the important thing is that code is not clean on the first pass. At least for me, it's never clean on the first pass, and I always need to go back on it and improve it. And that's okay, I guess. That's how it works. When I do that in 10 years, maybe when I've done that a lot of times, maybe I will be able to skip the first step and directly write clean code. I don't know, but I'm not there yet. Okay.
Excuse me, Eli, maybe another remark. So of course we again have the problem that it's a very simple example and this kind of principle are more convincing on big code and so on and so on. Mm-hmm. But just wanted to mention that when coding we mustn't have the opposite behavior of wanting to be too clean. I will explain what I mean. For example, for something that is that simple, in fact, you write it as you think it the first time. It's very simple. It will work. And I think, in fact, that your first version was not so bad in the sense that if, for example, if you will never use the function square root of positive, where is it? Square root of positive value. If you will never use this function elsewhere than in square root, for me it's very fine not to define a subfunction and just to put the code of that subfunction in the big function.
Well, I disagree.
Because it is very simple and because hopefully you won't have to modify this code. But what I would defend as a good behavior is to say, okay, the day that I have a problem with that code, it must raise the red flag in my head and say, okay, if I have to modify that code, then I want to make it clean first.
So, yeah, I understand your point. Maybe it's not worth the effort making this function a function. It could be directly there. But I disagree. I disagree because even if I'm never using this function anywhere else, I think it's worth writing it. It makes the reading of the code very much more clearer. It means, for example, why would you read the function square root? Maybe you want to make sure that those cases are tested and what are their behavior. And so you don't need to understand the rest of it. It's done. The rest of it is just taking the square root of a positive value. And so you don't have to go, reading those lines.
I perfectly understand what you mean. Just what I was saying is that very often converting bad code into good code is a long way. It's an ongoing process while you are working on your project. And in fact, for the most simple things, you don't need to spend that time until the moment when you have a problem with that part of the code, you want to extend that part of the code, you want to do something with that part of the code. But if the need never arises, then you have gained time by leaving code with not all the sub-functions that you mentioned.
Okay, yes, fair point. That's something I'm going to talk quickly at the end, how to improve code. Yes, what are the priorities and how to organize. So about bad comments, I used to think that every function I wrote needed a comment explaining what it was. Every argument I wrote needed a comment explaining what it was. But no, if the name of the variable is clear, you don't need a comment. If the name of the function is clear, you don't need a comment, unless, of course, you are building automatically a documentation, in which case, yes, of course, do it. And yes, introducing functions can be a way to kind of make a comment, and it's a better way to make a comment. I guess that's also something I wanted to say about it. Naming this guy is one way to make this comment, and it's that you are using Newton algorithm, and I think that's a better way to use this than a comment. Okay, what I said about functions actually applies to classes. There is this single responsibility principle that people mention from time to time. It means said in a biblical way. It's do one thing, do it only, do it well. I like it, but it sounds like it's God telling you to do it for no other reason that God told you to do it. No, it's actually very useful, and I hope with the previous example I showed you a bit what you gain from it. So again, the names, they should give a lot of context, but they can also use the context of the class. And methods should be verbs. So here's a bad example. We have a class user. Okay, maybe we have users in a project. And then we have user address, and we have a user underscore address attribute. Of course, that's perfectly ridiculous because what is it going to be? User dot user address? No, we shouldn't need this user here. It's completely redundant. On the other hand, what is not clear is the address. Are we talking about physical address? Are we talking about like streets and things like that? Are we talking about IP address, postal address, whatever? So if this could be improved, this name could be improved, we don't need this user. It's not giving us more context that we already had, but we could add useful context to it. And yes, if we want to access address, we can maybe use directly the attribute of it. If you want to make a method out of it, it should have a name, to a verb, I mean. Okay, but that I guess everyone knew. Okay, when do we need clues that we need a new class? It's not always obvious that we need a new class. So there are some tricky cases that I didn't realize. It's when a function has a lot of arguments, or it defines a lot of variables that make sense together. You see what I mean? That are of the same type, belong to the same things. And when that's the case, sometimes we can make a class just for those arguments or for those variables, and that will make more sense in the code, make it more readable. But also quite often it turns out that this class is going to be useful also somewhere else. And we did not see that first. So here's one of the examples I had when we didn't want code duplication and we were defining all those things, the number, the verb, the plurals. Those three things clearly have a linguistic feeling about them, so it could make sense to make a class to regroup them. And that's what we did on the first example. So that's what motivated the creation of a class on the first example. Okay, and also another indication that another way to see a class and think, maybe I can, it needs some refactoring, is when a class has several responsibilities, is doing a lot of different things, in which case you sometimes want to divide it. And I have an example that I wrote recently after reading the book, so I'm going to present it here very quickly. I wanted to write code that was defining a distance on text. We needed a distance not only on text, but between sets of text that could be weighted. The weight represents how important the text is. And we also wanted a distance to be able to evolve, meaning that if someone came to me and told me, oh, actually the distance between those two sets of text is in this interval, I could change my distance to fit this so that the new distance between those two sets would be in or closer to that interval. See what I mean? So okay, I needed code to do that. And this is how I structure it. First, I decided to rely on notions like TF-IDF, meaning that I'm going to transform sets of text or text into vectors that looks like distributions on the set of words. So in order to do that, that means I'm going to represent everything like matrices, and define vector spaces and those kind of things. And to do that, of course, I need to handle matrices, vectors, and and all of that. So I decided that I would have one file that contained all my matrix operations, vector matrix operations, and all the other files would know nothing about what implementation I chose. So I chose to rely on SciPy, but if I change it, if I decide now that I'm going to rewrite everything because I have a more efficient implementation in mind or a different package, I just have to change what is inside this file. That is a bit long, but fairly okay. Observe that all the functions are very small, as they should. And I just have to change this file and nothing else in the rest. So that's good thing. Then I have a vector space that I build over those matrix operations. It's telling me how to turn my text and my words into vectors. And it's also building the matrix of co-occurrences. Then over this vector space, I can define a distance. And once I have this distance, I can also give this distance the ability to learn from the things. So notice that the distance heritates from the vector space here, and that the learning distance heritates from the distance. So I could have written just for those three things, I could have written just one big class with all those methods, just put them together. That would have changed nothing to the actual behavior of my code, because the user is going to use only this class. But it would have mean one huge class, well, huge, not really huge, but yeah, kind of big, doing several different kind of things. And I like it way better. It organizes my code way better to have it separated that way. It makes testing also, my test files are shorter because there are less things inside each of those aspects. And when one aspect fails, I can see, is it the vector space that is responsible for the bug? Is it the distance, the transformation to the distance, or the transformation to a learning distance that has a bug? So it helps me a lot, although it's doing absolutely nothing for the user in the end. So yeah. That's an example where in the past I would have just written one big class grouping those three together. Also, something else I realized, sometimes I want to work with words. Say a text is a bag of words, lemmatized word, but doesn't matter. And sometimes I want to work on factors, saying that I'm going to transform a text into a bag of its factors of size between, let's say, 2 and 5. That's usually enough. And so where should I, change that? And I realized that this part, I don't want to write my one code for, of course, words and one code for factors. So I realized that this choice had to go up. So actually my distance is not on text, it's on iterables. It can be kind of anything, just hashable iterables. And the item of my iterables are going to be either words or factors. And so if you want to use that for NLP, you have first to transform your text into its set of factors and then use this distance. So I think that's I'm happy about this this change. It gives me a lot of flexibility, and yeah. Okay, so now I don't have much time, but I'm almost at the end of it. Debug and tests. I want to talk about it. So in the past, I did not write tests, and to debug, I would write print everywhere in my in my code, hoping to locate the bug. Finding a bug meant for me the beginning of a huge struggle that could take hours, days, or sometimes a week to find actually where it was. It was very depressing to find a bug. I knew that testing was good in theory. Many people had told me that. Some people even started with the test and then wrote the code corresponding to the test. But actually, the problem was not my inability that I didn't have the moral strength to write the code, the test. It was that my code was written in a way that made it very hard to test. So I needed not to work harder on the test. I needed to work harder on the code, and then the testing became easy. And it took me time to realize that. So if that helps someone, I hope it's worth it. Why writing very small functions that do only one thing and work at one level of abstraction helps a lot for, when I say function, I also mean methods. It helps a lot for the tests. Bugs are easier to locate and tests are way easier to write. Because, well, the functions are short. So if there is a bug, it's going to be in a small function. It's going to be easier to understand what is going on. The function and the methods, they do only one thing. So we understand what is going wrong. We have few arguments. So that means when we test, we don't have to explore a huge space of possible arguments. Yes, when to write code is also very important. So it's not, I don't write all my code and then all my tests, but I don't do the reverse either, write all my tests and then write the code, because when I write the code is when I do this cleaning process, reveals the structure. And so my test would be on the wrong functions if I had started with my tests. So I know many people start with the tests, and those are very good people. I just don't know how to do it yet. The way I do it currently is I build like a house. I put the bricks, that's the code, and then I put cement on it, that's the testing, and then I can put bricks on top of my previous row of bricks. That's new code. And I know when I write the new code that when I'm going to test it and find some bugs, it's going to be on the new code. And if it's not on the new code, if it's on the base code, that's okay, because now I don't feel bad about it. I'm feeling actually happy about it. It means I'm going to find a new test to add to my old testing and make my code even stronger and more reliable from now on. So I know I can trust this code that is at the bottom of it because the cement is strong there. And yes, I could do better. I could write my test before my code, but I don't know yet how to do that. And also my test, the code of my test is not very clean. And the author, Robert Martin, who probably knows a thing or two, insists that the test should be as clean as the code, that you should work on cleaning your test as much as you work on cleaning your code, because if it's not maintainable, you're going to be lost at some point with it. And I guess it's just that my projects are small enough that that does not happen yet to me. And when it does, then, well, I will have to evolve again. That's it. I've finished my presentation.
Thanks, Eli.
Maybe to be the devil's advocate again.
Yes.
Just about the nested the several level structure of classes, for example. I think once again there is a balance to find between writing code quite quickly to do one thing and being able to expand it later. What I mean, for example, if you make a project on giraffes, the animal with the long neck, and you want only to work with giraffe, maybe you will make one class with all what that a giraffe can do. And if you never implement another animal, then doing one class is very fine. And because in theory, you could implement one level for a living being, animal, a vertebrate animal, mammalia, and so on. But it's totally useless to do it if you never use anything else than giraffe. But if later one day you implement another mammal, for example, you can implement a superclass mammal for the giraffe and the dog, for example. And with an IDE, it's in fact quite easy to move some methods that were in the giraffe to the superclass and to reorganize, refactor your code in order to be able to expand it.
Yeah. One remark about that is the top-bottom or bottom-up approach. If I write the class giraffe, and if I in the spiritual world at that time, and I want to make things very abstract, and I think, oh, I'm going to write good code this time, and I don't understand what it means, so I start to write a living being class because I think, oh, that is more abstract, so it's better to start there, and then mammals, and then only giraffe. And of course, if I do that, the moment I write the giraffe class, I realize, oh, but actually, my giraffe needs some things that were not that don't fit well with the previous things I wrote on mammals and living beings, and so I will have to change a lot of things again and again, and that's going to be a mess. On the other hand, if I start by writing my giraffe class, and then when I read it, I realize, this here I have code duplication there and there, so maybe that's because, well, yes, my giraffe and her babies, they are both, I don't know, mammals, so maybe it makes sense during the refactoring process to create a class there. And if it comes from that, then it works well in that direction. At least for me, when I work, in the old days, when I tried to make clean code, I tried this top to bottom approach, first living beings, mammals, and then giraffe, and it never worked. It was a pain.
Yeah,
but now that I go the other way around, I sometimes create some classes that are not going to be maybe used again, or not a lot, but and that looks a bit abstract, but that's not how they appeared. And it makes my life easier.